Hello, Earth Science kids. I want to talk about the three ways to transfer heat, and I've said the because there's really only three ways to transfer heat. So, what is heat? All right, what's the difference between a hot object and a cool object? Here it is. High temperature means fast-moving atoms. That's what it means. If something has high temperature, the atoms are wiggling and jiggling like mad inside it. They're moving fast. Low temperature, therefore, means slow-moving atoms. That's it. So something with low temperature has slow-moving atoms. So let's see how this turns into three ways of transferring heat. Okay? So, first, radiation. Vibrating atoms send off energy in electromagnetic waves. Light, infrared, ultraviolet. So, when an atom is vibrating, it's going up and down, vibrating up and down. If it's vibrating fast, the waves it gives out are shorter waves. If it's vibrating slower, the waves it gives out are longer waves. In any case, it's giving off some of its energy in radiation. So vibrating atoms send off energy in electromagnetic waves. Example would be light, infrared, ultraviolet. For example, a star might be so hot it's giving off ultraviolet light, lighting up the environment around it with ultraviolet light. Well, things on Earth, things that you meet, are not nearly that hot. In fact, you have to take a hot poker and put it in the fire for a long time before it ever starts glowing red and giving off light. Most all the stuff that's giving off radiation, giving off its heat as radiation, is giving off infrared energy. If you take your two hands together and rub them very, very fast and put them right next to your cheek, not touching, about an inch away, you could feel them. Your cheek can feel the heat there. You're feeling infrared radiation. That's one way to transfer heat. Another way is conduction, right? Conduction. What is conduction all about? Well, vibrating atoms touch other atoms and make them vibrate too. If you have an atom here, it's vibrating very fast, and a cold atom that's not vibrating, you bring them together and the cold atom will start vibrating too. It will warm up. If this was metal and I had just stuck it in the oven and then I took it out and touched it, ow, I'm feeling it now. Atoms in here are vibrating very fast when I touch it. The atoms in my hand start vibrating very fast, and I'm getting burnt. So, first is radiation. The vibrating atoms are sending off energy in electromagnetic waves, right? This is the electromagnetic spectrum you can find on your reference tables. Second way is conduction. Vibrating atoms are touching other atoms and making them vibrate too. Well, the third way has to do a little bit more with conduction, and it's convection. Convection is in a fluid. The vibrating atoms, like any vibrating thing, will spread out. They'll lower the density, right? When you heat up an object, it expands. In fluid, that happens as well. So in fluid, if you're heating up water, the water molecules are vibrating very fast and they expand. They become less dense and therefore they rise. So this would be an example right here. If you have this beaker on top of a flame, the water will get hot, lower its density, begin to rise. Then as it cools off, it is increasing its density and it'll come back down again. Same is happening with a flame. Why does a flame go up like this? Well, what's the heat here? Well, much hotter than the air around it. So the hot air here is rising, making that characteristic flame shape. All right? So three ways of transferring heat, and only three ways of transferring heat. Radiation, giving off electromagnetic radiation, light, infrared, ultraviolet, stuff like that. Conduction, because the vibrating atoms touch other atoms, make them vibrate too. Or convection, and just the heating of stuff in a fluid, and a fluid could be water, could be air, can be any liquidy thing where motion can occur. When something becomes less dense, it's going to rise. When it becomes more dense, it's going to fall. That's all. Three ways to transfer heat. You heard it here.